So, going back to our discussion earlier then, we now have a better context of what was that little network cloud that I described earlier. And that could be something like Vine, or could be something like GroupVPN that creates the virtual network that allows our virtual appliances to finally talk to each other. So now if you're deploying virtual appliances running Hadoop, they will get IP addresses on a virtual namespace, a private namespace like this example. And you can deploy many of these machines, and each one gets an IP address, and they're all able to communicate with each other. So now you not only have a virtual appliance where you can encapsulate the environment, Hadoop, MPI, Condor, etc., but also you have the virtual network that can be encapsulated in the virtual appliance itself. And one example of this approach is a particular virtual appliance that we call the Grid Appliance. This is a project, again, available on FutureGrid, and a project from the University of Florida. And here, what you have is an appliance that has a version of Linux optimized for size, and you have middleware, clustered middleware. In particular, we currently support Condor, MPI, and Hadoop. So with this appliance, you can deploy, again, on a virtual network, multiple nodes, and you get a Condor pool, for example, automatically configured at the end of this deployment process. And that could be within a desktop, that could be across desktops in a LAN, that could be on FutureGrid, that could be on commercial clouds, and that could be spanning across multiple domains. The virtual network will always show the same abstraction of a virtual network to the cluster software. So what's inside this specific appliance that's available through FutureGrid is the host operating system, a grid or cloud stack, and the glue logic software that is needed for configuring this thing. So setting up a DHCP address, discovering resources using multicast DNS, and interaction with the distributed hash table to store and retrieve information, interaction with virtual machines, cloud provisioning software like Nimbus. So with this, we can have one image that you can deploy on a number of platforms. The Grid Appliance in particular works with VirtualBox, VMware, KVM, and you can deploy on a local desktop, on a local cluster, on FutureGrid, on a Science Cloud, or Amazon EC2, or any other provider. You may have to convert a virtual machine image, a virtual appliance image, but that's the system is configured so that it makes that process simple. And it makes minimal assumptions about networking. At the very least, all you need is a private address inside the virtual machine with a NAT virtual network device. So that's something we don't have time for a demonstration today, but if you want to go back and try the Grid Appliance on your own, as long as you have any of these virtual machine technologies, you can download the image, turn it on, and even if the virtual machine has a NAT address, you'll be able to connect to the virtual network. So what goes on behind the scenes for this to work, again, is the virtual network providing a DHCP address, and there's additional configuration that's specific to the middleware that we're using. So in the case of Condor, for example, the Condor scheduler, we use the distributed hash table to advertise that the Condor scheduler is running on a particular virtual IP address. And Hadoop and MPI can be configured in a similar way. To use these virtual clusters, again, you need to configure a virtual network using a web interface. And what the web interface will provide back to you once you log in and create a group, and or users connect to your group, they get a virtual floppy. And that virtual floppy is all that you need to provide to your virtual machine, your virtual appliance image, so that it can configure itself to join a virtual network. Now that can be using a graphical user interface. If you're using software like VMware, you just plug in virtual floppy into the proper location, and VMware will open it up automatically. If you're using a cloud provisioning software like Nimbus, you're going to use APIs available to copy that image into your virtual appliance. And then you can create a virtual cluster, run jobs, for example, for a class project, and terminate when the jobs are finished. Again, I don't think I'm going to be able to do a demonstration because of the lack of time and connectivity issues here, but I'd like to give you an overview of something that you can do on your own. If you're running Nimbus, for example, all that you need to do is create a virtual machine, instantiate a virtual machine, and on the machine Alamo on FutureGrid, you can name this version of the grid appliance, and with this single command line, you basically create a virtual machine appliance. And if you copy the virtual floppy into that virtual appliance that has your GroupVPN information, that virtual machine can connect to your own virtual private cluster. And then from that on, you can submit Condor jobs, you can submit MPI, Hadoop jobs, and there are tutorials on the FutureGrid website that describe step-by-step how you can go through these examples yourself. If you also go to the Grid Appliance website, if you Google Grid Appliance and go to our webpage, you can download the desktop version of the Grid Appliance and run using VirtualBox or VMware. So, how is this used in education and training? So the idea here is you'd like to be able to teach distributed systems, grid computing, cloud computing, these technologies using the actual tools that students are likely to use when they actually are ready to use applications that they learn about. So it's important to have experimental work in systems research and to use distributed systems in general. And in FutureGrid, it provides this nice capability that serves as a testbed for not just research and collaboration and experimentation, but also allows for a nice platform for education activities. And in fact, several classes, and this summer school is another example of a education and training type activity that uses FutureGrid. And one of the nice things that these virtual appliances provide is not only they make it easier for people to get started, so you can just deploy a virtual machine image like I described here with a single command line, you get a virtual appliance running, configured to reuse Condor. But it can also allow people to create their own environments and to share these environments. So on FutureGrid, you can create a virtual machine appliance, and you can make others aware of your virtual appliance, and they can reuse the environments that you create for your class, for example. Not only presentation, documents, manual, tutorial, etc., but the actual image with the software that one might be using for hands-on exercises. So for this, what we have in FutureGrid, two major components are the virtual appliances, these things that I described up to this point, including support for clustering, which is quite important for distributed system grid cloud computing applications. And the FutureGrid portal and the ability for users to share virtual appliance images. So FutureGrid then becomes an aggregation hub for these executable appliances and documentation that comes with them. So as a user, you can go to FutureGrid, create your class, and set it up and manage users using the FutureGrid portal. So the way to do this is through the portal, you create a project, and that could be a class, could be a workshop, a short course. And once that becomes approved by FutureGrid, and that usually does not take long and can be applied at any point in time, you have access to a resource that now users can be added to. So users will also, the students in the class, for example, will create accounts also using the FutureGrid portal, and you, as an instructor, for example, can authorize them to gain access to FutureGrid resources. And then the students can go onto FutureGrid and interact with FutureGrid to start virtual machine appliances and create their own virtual clusters, for example. So there are a number of classes that have used FutureGrid in different occasions and for different goals and different sizes. UF, University of Central Florida, Puerto Rico, Piemonte Orientale in Italy, University of Mostar, Croatia. Just the last couple of days, a couple more universities have signed on. Distributed Scientific Computing class at LSU has used FutureGrid, and a number of tutorials, workshops, and summer schools like this one have used this system successfully for education.